Hello. Welcome back to this demonstration. I'm starting from the course content, where you could see here that we are now going to be able to use what's called the big blue button. This is the new functionality that's available within the Moodle space. I wanted to make this presentation with consideration to the exercises that we had to realize on machines, where we had to compile some Cuda-based source codes, and of course we need to have a GPU in order to execute that, and it has to be NVIDIA type GPU. And noticing that there is some difficulty to have GPUs on most of the machines, so as if you remember, we tried to get access to the AWS cloud platform. But it turns out that things are not going, have not been so easy to manage with the Amazon Web Services. So one quick research, if you make a search, for instance, for free cloud machine with Cuda GPU, actually this is what turns out to be the top 3 results. So the first result is relative to the cloud GPU server that's called Collaboratory, or for short Collab. And this is a service that's provided by Google. The second service that's interesting is relative to the platform that's named Kaggle. It's a website, that offers massive data sets and allows competition between those who find the best results on these data sets. And there's also a couple of other services. Honestly, I did not check on the Amazon SageMaker on this link, or Jupyter. I just went straight ahead to the Collaboratory, and this is what I found. Actually, just before that, some other links. This is not Collab. This is what's called Collab Google Cloud GPUs, and it turns out that you have a free access of about $300 when you are it's for 12 months, and this is very interesting. So you can check here the credit that I had when I made the subscription. It could ask for a card number, but I don't have money in the card number that I had, and it worked. So here's another service that's called Floyd Hub. So I'm showing these services because you can consider them as your project. So if you're interested into trying to make some Cuda based source code work on, for instance, maybe on Google GPUs, or maybe on this platform, or you can also consider one of the others, like the Kaggle kernels, or the ones shown here, Amazon SageMaker or Jupyter Notebooks. It will be interesting, and it's a plausible contribution that you can bring. Even though I would recommend that you check on some research work and then try to make execution of their source codes. So what I'm going to show here is relative to the first choice, which is called Collab, and here it is. If you go to the Collab, here's the interface that you have, and I prepared this incognito link. So basically you will end up on this first page in collab.research.google.com, and you can create a new notebook, for instance, starting from here, and you will be on a very new page where you can copy and paste source code and give execution for it. So here's a tutorial that's I'm going to share the link for this tutorial. And the idea behind this tutorial is how to activate GPU testing, GPU capabilities on this Collab service. So I just want to remind you that we are seeking to execute some Cuda code on a cloud-based machine. So how do we make it? First, let's go to runtime, change hardware GPU. So I'm going to go to runtime, change runtime, and I'm going to check GPU, and I'm going to save it. Okay, perfect. Then I'm going to just copy and paste this code. And it's a bunch of code that actually deletes the Cuda version that's already present within the server. So this is the server. So I just have to pass this. I'm just going to make Control V, and then I run it. Actually, it's going to take some time, depending on the connection. First is connecting, then it might, yeah, so now it's initializing. And then you will see some results. Yeah, so this is working. It might take some time depending on the connection, but it's very interesting how fast it is on the actual connection. So here you will have the folders. You have some files by default. I just want to mention that the files that you will have here in your project might be deleted. You have almost 37 storage, but they are not permanent, so you will have to copy them back to your drive or maybe to a GitHub. So you could see here Github Repository, and I will tell you in a moment about how to make some GitHub repositories for short repos. So once you have this, you will be installing the brand new Cuda version. So this is a webget, wget link. You will get some Cuda version. This is exactly what we did in our class. If you remember, when we did try to have a machine in our institution in Github, where we had a Cuda-like version. So these are the 5, I would say, instructions that we could execute, and then we could check how this is how we call an executable. We place an exclamation mark, and then this is the command. If we place this command, it will work. Yeah, it will give us the Cuda version. And then we could also add some extra functionalities. This will allow us to run MVCC from the command line. This is going to allow us to place directly some code and get the results. And this is the source code that we could try. And I already did check on this. I'm going to get down if I check. Yeah, it's finished. So you could see here the running has stopped. And just before I show you the rest of the operations, so I'm going to launch the copying. I'm going to create a new code, and I'm going to pass this. Control V, and then I'm going to run it. So it's very impressive how fast this downloading is going to be. So this is about 1 gigabyte, 1.5. You see here. In my case, it took me a while in the Github, but here it's very, very fast, and the rest of instructions are there. So I'm going to get back to the other instance. So this is the same tutorial we had, and this is the instance that I had. And here you could check on the link. So this is the first result. These are the text prompts that resulted. Then this is the second set of commands. So you could see here that I did already make the installation, and after a while this is what I get. And when I try NVCC version, yeah, it works. And when I try to call only the compiler NVCC, it tells me that it doesn't have the file. So what I did is, what you can do is that you can just upload a file. So in my case, actually I think that the folder has been deleted here, so I'm going to just make it. So I'm going to just create the same folder, this one. So I'm going to copy it, copy, Control C. I'm going to create a folder, new folder, Control V, right. So in this folder, I'm going to check for the maybe I'm going to check for the first sample. So I'm going to just drag and drop the square code to this folder. Here it is. Uploaded file. So he's reminding me that uploaded file will get deleted when the right time is recycled. So we will need actually to copy back all the files to our own space or download them. So I think that once I reconnect, right? So it works. So I'm going to just activate this command once again. So he's telling me GCC error square no such file or directory. I'm going to refresh this. Alright, so maybe he's telling me that it depends actually where we are actually in the so I'm going to check. I'm going to type maybe I will go to the end of the stack, so I'll be there. I'm going to add the source code and I'm going to type ls and I'm going to play it. Actually not ls, pwd. Right, so this is just like if we were in a Linux. So yeah, I have to go to the main folder, cd change directory. Right, I did check on there, so the idea was, solution was very simple. Actually, all I had is to copy the path and then create a new code, and I had to place cd change directory and just paste the code and then run it. And yeah, here we are. And I could just demonstrate, delete the file, the executable, refresh. And all I had is just copy this command. I'll just run it once again. So this is the compiler. Interestingly, this is running on the web, on the cloud. So you see here the execution of this command is correct, and this is the result. I now have the square, and all I have now is to run it. So maybe I will add a new code here. Maybe I'll delete this line. I'll go here, and all I have to run it is just place an exclamation point, dot slash the name of the square, and yeah, normally things should be working. Oh, these are the zeros. So I think that the source code that I did use here is not the right one. I think that this is the source code where the kernel is empty. Let's check it. 3, 2, 1. Yeah, this is the empty source code. So I'll be checking on the correct version corrections. I'll be going to the square.c.cu. Right, so I'll be just, as I'm lazy, I'm just going to copy this one. Yeah, here it is. So all we have now is just take this one, change to 01 for this one, and then run it. So it will normally replace the square just to make things correct. So I will get my new square, and all I have now is to run it once again. Et voila! So you now have the result of the execution for the new Cuda code on cloud and on a GPU. Finally, yeah, we did it. So the next step is going to be relative to having the problem set. Remember this? Remember this problem set where you have to install OpenCV? And as we are working on a Ubuntu Linux-based machine, we have to go also through a set of steps in addition to getting Cuda. So we have also to get a set of steps in order to get the OpenCV compiled and installed. Actually, there is a very common OpenCV version that's based on Python. And actually we do not use Python in our project. In our source code we are based on what we have here is something based on OpenCV library with the C++ language. And actually using Python is a lot easier. Maybe we will have the chance to use it. But don't look to these kind of solutions. Actually what we are going to focus on is rather based on this new tutorial where I will give you the link. And actually this set of commands actually allows you, first of all, this is TensorFlow. This is the machine learning API from Google that you could try, and it will be very, very interesting to use TensorFlow for your projects. Remember, I just can't remind you enough about the projects you're going to choose. And then once you have that, then you could check on OpenCV installation for C++. And this is what I have here. You already check, have seen, I think that you have seen that I have all of these commands. So this is the execution. Here it starts. So this is the compiler installation on Linux. So I think that, yeah, these two commands are relative to compiler. This is the update and upgrade functionalities that will be called. So I think this might be the result for the update and upgrade. And this is the prompts that these are the prompts that we are going to have. And then these are the libraries that will be required. So including build essentials, CMake, the compiler, Git, and all of these codecs and libraries that are mentioned, I think, somewhere like this, like here. And it will take some time, and then this is what you're going to get. Now going to more OpenCV related libraries. The following command is needed for image, to process images. This is to process videos. Just coming right from there. And taking some time. Here we are. And finally the GUI and the optimization. Actually, after all of these libraries, here we get to the OpenCV 3.4 version. This is the zip extract archive. This is the installation of the unzip utility, and here we extract the OpenCV. And you can see here, I think this is the OpenCV zip for archive, and this is the result obtained. And once we have the OpenCV installed, actually we need to build it. And on Windows we already have this build folder existing, but on Linux it will not be there. So this is the new command. So we go to the OpenCV, we make the build folder, we enter, and we make the CMake with all of these options. And these are very, I would say, minutiously selected options that we profit from, and it will take some time. I think that this is the most time-consuming step, and I think that I kept a screen capture for this operation. Sorry for the lag. Yeah, so going a bit further, when you finish all of this, you will have your own OpenCV version ready for install, and you can go right from there. And what you can see here on this folder, on this tutorial, once you're finished with OpenCV installation, you can get a cloning of a repository from GitHub, or you can copy your files from Google Drive, or you can just drag and drop the files just like I did here, copying, dragging and dropping the folders, depending on the complexity. So what I did is that I already prepared a repository for our project. So what you can see here under my own GitHub repository, Bassem Sadiq /cc.gpGPUs for general purpose graphic processing units. I already gave these two folders. This is the problem set number 1, and this is square.cu file. I think that this is the whole problem set, and I think what you need is exactly within this folder. So all these elements need to be, I think, copied and placed within the project. Yeah, so I think that we can upload, I think, from this is going to upload from a set of folders, so you could do this. I think that you can also download some stuff, open view on GitHub, so you can link with a GitHub save on GitHub. And this is what I did here when I saved this project, and this is what I did get on the GitHub repository right there. So just this is the result. So you can just copy, and normally once you have all these results, you should be fine and ready to get the results. Right, so just to mention, there are some other ready to use Colab folders. All you have is just search for them, and they are ready for with OpenCV configured, and also with GPU configuration active one if you really need them. But I think that I will share with you using this link the folder of this repository, and all you have is just go back on these operations. So with that, I hope that we have all the requirements satisfied in order to fully go the full path of our learning with GPU-based programming.